Hey everyone, and welcome. Today we are jumping into something pretty wild, a surprisingly clever way to trick an AI's safety features. It's called the Inter-Turn Modality Jailbreak. So let me ask you this. How do you trick a super smart AI? One that's supposed to be really secure. Well, it's not about some single genius level command. Nope. Turns out, it's a lot more like pulling off a carefully planned digital heist. All right, so let's get into it. Because even the most advanced AI models have a blind spot, a little crack in the armor that attackers have figured out how to exploit. And here it is, the official name for that blind spot, the Inter-Turn Modality Jailbreak. So what does that even mean? Well, basically, you confuse the AI by constantly changing how you talk to it. You might start a conversation by typing, then follow up with an audio clip, and then send an image, all to throw its safety systems off balance. Here's a great way to think about it. Imagine the AI's safety system is like a high-security building. You've got one guard at the text door, another at the audio door, and a third at the image door. The whole trick, the reason this attack works, is that those guards, they aren't talking to each other. By hopping between entrances, you're basically slipping through the cracks in their security. So what does this heist look like in action? Let's break down the anatomy of the attack step by step and see how it's done. The whole strategy hinges on something called a multi-turn escalation. See, the attacker has a harmful goal, but they don't just come out and ask for it. No, they build up to it little by little over a few conversational turns. And the secret sauce? They change the input type, the modality, at every single step. Okay, let's walk through a real-world example from the research. Say an attacker wants the AI to write a phishing email. Step 1. They start with a totally harmless text prompt, something innocent like, hey, can you tell me about marketing psychology? Just to get the conversation going. Then, for step 2, they escalate a little, but this time they send the prompt as an audio file. And for the final move, step 3, they hit it with the real request. Draft a high-urgency phishing email, but get this, they put that text inside an image file. By constantly switching between text, audio, and image, they completely mess with the AI's ability to keep track of the conversation's context. It just gets confused. So the big question is, does this actually work? Well, let's take a look at the success rate, which is frankly pretty alarming. The answer is a big, resounding yes. It works, almost perfectly. Researchers found this attack has a success rate somewhere between 90 and 100%. I mean, that is just a staggering number. And here's what that really means. The AI's refusal rate, its ability to say, no, I can't do that, it just plummets after the very first time the attacker switches from text to audio or audio to image. Those safety guardrails that are usually so strong, they just kind of crumble when faced with this kind of multimodal confusion. And the stuff attackers were able to get is really serious. We're talking about everything from code for malware and detailed phishing scams to instructions for making weapons, getting info on controlled substances, and even potential biological threats. It's a pretty scary list. Now, you might be thinking this is just some obscure problem with a couple of niche models, but it's not. Let's look at which big-name systems are actually vulnerable. Yeah, this isn't a small-time issue. The list of vulnerable models includes some of the heaviest hitters out there. OpenAI's GPT-4o, Anthropic's Claude, multiple versions of Google's Gemini, and even popular models from QN. This really signals that it's an industry-wide problem. Okay, so it's a serious vulnerability for sure, but the good news is it looks like it's fixable. So let's pivot from the problem to the solution and see how we can strengthen those defenses. The research actually lays out a pretty clear 3-step plan. First up, cross-modal context tracking. Remember our security guards? This is basically getting them to finally talk to each other. The AI needs to maintain a sense of risk across the whole conversation, no matter how you're talking to it. Second, unified semantic filtering. This just means the same strict safety rules have to apply to everything, text, audio, and images, no loopholes. And finally, provider-aware testing. AI companies need to be actively trying to break their own systems with these kinds of attacks. It's called red teaming, so they can find these weak spots and fix them. This whole jailbreak is a perfect example of the constant cat-and-mouse game of AI security. And it really leaves us with a huge question. As we're racing to build these incredibly powerful AIs, how do we make absolutely sure that their safety features are keeping up? That is the challenge. Thanks so much for watching.